Now we're going to use the sum to product identities. So we have sine plus sine, sine minus sine, cosine plus cosine, and cosine minus cosine. What we want to do is we want to find the exact value of the sine of 5 pi over 12 plus the sine of pi over 12. So we are using a sine plus sine. So we are up here in our formulas. So sine of alpha plus sine of beta is 2 times the sine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. So if we rewrite this, we get 2 times the sine of 5 pi over 12 plus pi over 12. Oops. All divided by 2 times the cosine of 5 pi over 12 minus pi over 12, all divided by 2. From here, we need to simplify. So we have 2 times the sine, and we need to figure out what that angle is inside. So we need to add and divide right here. And I'm going to do that over here on the side to show you how that works. So we have 5 pi over 12 plus pi over 12. Well, the nice thing about this is we already have common denominators, so we can just add the top. 5 pi plus 1 pi would give us 6 pi over 12. And simplifying 6 pi over 12, 6 over 12 would just give us pi over 2. Now that's the numerator, so that's from adding the top, and then we also have to divide that by 2. So our next step is to take that pi over 2 and divide it by 2, which is the same thing as taking pi over 2 and multiplying by a half, giving us pi over 4. So when we add these two together on the numerator and then divide it by 2, we end up with pi over 4. So we want to take the sine of pi over 4 times the cosine, and now we have to do the same thing in here. So we're going to take 5 pi over 12 minus pi over 12. And again, we have common denominators, which makes it a lot easier. So we can just subtract the top. 5 pi minus pi is just 4 pi over 12. And simplifying 4 pi over 12, 4 over 12, we can get pi over 3. And then again, we have to take that pi over 3, which was the numerator, and divide it by 2, which is the same thing as taking pi over 3 and multiplying by a half, which gives us an angle of pi over 6. So we're taking the cosine of pi over 6. And then what we can do is we can go ahead and we can actually evaluate. These are some of our special right triangles. So we know what the sine of pi over 4 is, and we can also know, or we could find, the cosine of pi over 6. So if we think about it, sine of pi over 4, I'm going to move this up a little bit for us. Pi over 4 would be in the first quadrant with a 45-degree angle. And across from a 45-degree angle is the square root of 2 over 2. So I can rewrite this as 2 times the square root of 2 over 2. And then the cosine of pi over 6, that's going to be in our first quadrant with a reference angle of 30, which means this angle is 60, and across from a 60-degree angle is the square root of 3 over 2, which is where the cosine is. So this we could write as square root of 3 over 2. And then it's just a matter of multiplying everything together. I can multiply 2 by square root of 2 over 2. These 2's would just cancel out, and I get the square root of 2 over 1 times the square root of 3 over 2. Multiplying across the top, since they're both underneath square roots, we can multiply the 3 and the 2 together to get square root of 6. And then we can multiply 1 times 2, which would give us 2. If you have any questions about this, let me know. Otherwise, there are 2 in the try this that I want you to try. So go ahead and try letter A, check your answer, and then go ahead and try letter B. If you did letter A correctly, you should have ended up with negative 3 times the square root of 3 minus 3 times the square root of 2 all over 4. And if you did letter B correctly, so if you haven't finished letter B yet, pause it again. If you have finished letter B, you should have gotten letter B to be negative square root of 6 over 2. Please let me know if you have any questions.